All right, this is 7-4, 7-5, similarity in right triangles and proportions in triangles. I'm going to try to move through this smoothly. I keep hiccuping a little bit. Let's read this first part and make sense of it. For a right triangle ABC, this triangle right here, ABC, this bigger triangle, the biggest one, the two small triangles put together make the biggest one, right? That is similar to the smallest one, the smallest one being ACD, and the medium one, CBD, right there, okay? Please notice the sequence, right? AB is the hypotenuse of the big one. AC is the hypotenuse of the small one, and CB is the hypotenuse of the medium one. BC, right? BC is the longest leg, right? So I go from hypotenuse to longest leg of the biggest one. CD is the longest leg, so I went from hypotenuse to longest leg, and BD is the longest leg of the medium, so I went from hypotenuse to the longest leg. I'm just trying to take this time to remind ourselves that order matters, right? Corresponding parts of congruent triangles are congruent, and corresponding parts of similar triangles will be proportional if these things are similar. So take your time to understand that these are not written randomly. They have an order and a logic to them. Anyways, so these things are all going to become similar. And why do they become similar? They become similar when CD, right? When CD in the largest triangle is dropped down as a perpendicular line as an altitude. CD is an altitude. So because this is an altitude in the larger right triangle, it breaks these things up proportionally for this and this thing become similar to this whole thing. So what do you call this altitude right here in this special circumstance? It's called a geometric mean. Meaning that it means a couple things. If you want a nice lecture, I don't want to get too deep into it right now, but if you want a nice video to go over geometric mean, I'm going to go over this in class right here. So here's your geometric mean. All I'm saying is that the short side of one triangle compared to the long side of that same triangle can make a proportion, can make a ratio with the other triangle, like the medium one, where the medium one has a short side that is the same as the long side of the other one. But who cares for right now? It's just the point is they're both it's a shared reflexive sort of property thing going on. And then compare that to the long side over there. So if I wanted to find what x was right here, I can use this geometric mean formula. I can say that x is equal to the square root of a times b. And why is it okay to use this formula? This is the proof of how it works out to be, okay? Short leg is to long leg as short leg is to long leg in these similar triangles. And so you can start plugging things in, right? If I cross multiply, then I have x squared. If I cross multiply, that would be equal to AB. And then to get x all alone, I would square root both sides. So that's how you get to that thing right there. So at number 15, they're asking us to use this figure here and to find SU, the geometric mean right here, SU. So how can we do that? Let's think about those numbers real quick. I got it set up over here already, okay? So I'm told that this is, I'm told that this here is 4 units. That this here is 12 units. But I don't know what this is. This is the SU I'm trying to find, okay? So all I know is that these things are similar, right? This is a right triangle here. That's a right triangle in there. That's a right triangle in the medium-sized one, okay? So I can make this thing. I can make this proportion. I can say that my 4 from my smallest triangle is proportional to its long side, which is x, the same way as the short side in the medium triangle, which would be x is to its long side, which is 12. So again, this is just my short, medium, and my long, medium. And over here, this is my short, small, and my long, small. Yeah? All right, great. So what am I? So there you have it. This is your 4 is your A, 12 is your B. I can just jump ahead. I'm gonna jump ahead instead of working all that out and just say x is equal to the square root of 4 times 12. Okay, or you can say x is equal to the square root of 48. But 48 is not a perfect square, so I don't want to write it as a funky fraction. I want to make it as clean as possible. So let me just go back over here for a second. Let me break this down. I know that if I have a pair, I can pull out. So 12 is the equivalent to 4 times 3. And I'm going to take this pair right here of 4s and pull them out. I'm going to say 4 radical 3 is the length of x. So you found x. So back over here, what is SU in this situation? SU is equal to 4 radical 3. That number, 4 radical 3. All right, here let's look at another proportion, okay? How about we just do look at another triangle, okay? Let's get RS. What is RS in this situation? All right, so RS is, if we look over here, it's the hypotenuse of my small triangle. And it's also the short leg. Yes, this is the hypotenuse of my small triangle, right? And it's also the short leg of my large triangle. All right, so I can make a ratio that compares my short to my hypotenuse and my short to my hypotenuse. So let's do that real quick, okay? And I have these things, all these triangles separated over here that kind of help you out a little bit, right? So these are all these blue greens represent the hypotenuses of the 3 different triangles, and then here all the vertical lines are the short sides, and all the flat lines, the horizontals, are the long sides. Just to help us organize ourselves, it's always nice to separate these things. All right, to solve this problem, again, I'm comparing the short side right here, which is 4. Excuse me one second. Comparing the short side 4 to the side I don't know, but I'm looking for, which is RS, the hypotenuse. So I'm going to call it RS, okay? So again, this is my short, excuse me. So this is my short from my small, and this is my hypotenuse for my small. And I'm going to compare it to the short of my large and the hypotenuse of my large. Okay, the short of my large was RS. There you see right there, RS, not given to me, but no, it is. The hypotenuse, however, is 16. All right, so now I have my A and my B. So I know that RS is equal to the square root of 16 times 4. Okay? Or 4 times 16, either one's fine. And this breaks down these are both perfect squares. So instead of multiplying them out, let's just break these down. That's just 4 times 4. And that's just 2 times 2. So this is equal to 4 times 2, which is 8. Okay? RS must be 8. All right, one more real quick. Number 14. Number 14 says, what is ST? All right, so what can we deduce from ST? Let's look at our triangles over here that are separated. I'm looking for ST over here. Well, I don't know what ST is, but I do know that my ST over here, my large triangle, is also in my medium triangle. So I can probably make a proportion real quick, right? I can say that this hypotenuse is to this long side of the medium as this hypotenuse is to the long side of the medium. And let's do that real quick, okay? I'm going to work that out over here. So let me see here with my pencil. So this short side, this is my hypotenuse side, so ST. So I go ST. ST is to my hypotenuse, is to my long side, which is 12 in the medium. So ST is to 12 as my hypotenuse, and the big one is 16. Okay, is to my long side in the big one, which is ST. I picked these two because I needed to have a shared side. You kind of got to recognize that where reflexive properties is going to be. All right, so cross multiplication happens, yada yada yada, and you can just go to the geometric mean formula, the geometric mean, which says that ST is equal to the square root of 16 and 12. Or what is that? So these things break down, right? This is 4 and 4. 4 and 4. This is 6 and 2, or 4 and 3, right? So let me break these down, okay? So, and I have 1, 2, 3, 4s. So for every one of those 4s, I have a 2 that I can pull out, right? So those are all gone, and then that 3 stays under. So my answer is 2 times 2 times 2, which is 8, radical 3. This number here is equal to 8 radical 3.